Welcome to our webinar today, everyone. My name is Justin D'Souza. I am a quantitative specialist here at Statistics Solutions. During today's webinar, we will be discussing how to select statistical analysis, how to simplify that approach. My colleague Isaides will be assisting today with questions during the webinar. If you have any questions, please type those into the chat box or the question and answer box. At the end of the webinar, I will also be doing a question and answer session to address any questions specific to today's topic. And we will be sending everyone a copy of today's presentation, along with a recording of the webinar. So let's dive in. We'll start out by me giving a brief overview of the services that Statistics Solutions provides. Then we will discuss today's topic and selecting an appropriate test. I will give a brief demonstration of our Intellectus software, which can help you to also select appropriate analyses. And we will conclude with a summary. On this slide, I have a couple hyperlinks that will take you to the previous webinars we've conducted, as well as upcoming webinars we will be doing in the future. So go ahead and check out those. We do discuss different chapters of the dissertation. So we tailor it to discuss chapter 1, chapter 2, the introduction, literature review, the methodology, results chapters, and discussion. So come join us if you've hit a roadblock in your dissertation. So for today's topic, we're covering how do you select appropriate analyses? And the choice of what analysis you decide to use is 100% dependent on what level of measurement your variables are. So maybe you're in chapter 1 or topic development, maybe you're in chapter 3. It really doesn't matter where you are in the process. At the proposal stage, you can start to think about research questions, right? You want to think of unique research questions, find a gap in the literature, formulate a study that is unique. So at this point, you want to start thinking about your variables of interest. That is, if you've selected a quantitative methodology. So the choice of what analysis you decide to use is dependent on level of measurement. It's also dependent on whether your statistical assumptions are met. So statistical assumptions typically include things like normality, homogeneity of variance, absence of multicollinearity. You want to make sure those assumptions are met. If they are not met, many times there is an alternative test you can run. A non-parametric test. So we will be touching on that. So first, let's define the 3 different variable types. We have continuous variables. Continuous variables are variables that fall on a continuum or a scale. Examples of these are test scores, temperature, weight, or composite scores. So say you're using a previously validated survey, like the job satisfaction survey, or maybe the multi-factor leadership questionnaire. If you develop a composite score from a series of Likert scale items, many statisticians today agree that that new variable is continuous, and you can use parametric analyses with them. This has been a debate for decades now. You can argue it either way. I prefer to argue the approach that composite scores are continuous because once you take an average or a sum of a series of Likert scale items, the possibilities of the score go beyond just the Likert scale. If you take an average, you can have decimals. You could have 2.3 or 3.2 as your scores. Those are not ordinal anymore. Those are continuous. The next variable type is nominal. So nominal is synonymous with categorical variables, variables that have 2 or more discrete categories, but these categories don't have an intrinsic order. Examples include gender, ethnicity, or passing and failing an exam. There's no hierarchy to any of these. It's a dichotomous variable if it has two possibilities, like pass and fail of the exam. Gender can be dichotomous if just looking at male and female, or it can be multi-category if you have gender as male, female, and there are other possibilities. Ethnicity could be white, black, Asian, Hispanic, so that is nominal, 3 or more possibilities. Ordinal variables are similar. It's kind of a subset of categorical variables or nominal variables, but the categories can be ordered or ranked. So examples of this include education level, less than high school, bachelor's, master's, PhD. There's a natural progression to education, so that would be ordinal, or an individual item, a Likert scale item on a survey on its own is ordinal. You have 5 independent categories, but there is a natural order to them. Strongly agree down to strongly disagree. So the first test family we will look at are correlation tests. And you'll see a sample research question at the top here. Is there a significant relationship between variable 1 and variable 2? In the final column here, I've provided examples of potential research questions that would fit each of these analyses types. So if you have 2 continuous variables, then you want to run a Pearson correlation. The non-parametric version to a Pearson correlation is a Spearman correlation. So a Spearman is used when you have an ordinal variable and a continuous variable. So something like, is there a relationship between education, which is ordinal, and self-esteem, which is continuous? Likewise, if you have 2 ordinal variables, relationship between education and what income bracket you fall into, that is also considered an ordinal to ordinal comparison, so that you could use a Spearman correlation there again. Now, something to note here is when you do a Pearson correlation, going back to the first example here, you want to check for assumptions of a Pearson correlation. And one of those assumptions is normality. You want your self-esteem and self-efficacy variables to follow a bell-shaped distribution. You want them to be normal. So if that assumption is violated or it's not met, then you can run a Spearman correlation instead of a Pearson correlation. So run the same comparison, but just run a Spearman instead, which is a non-parametric test and is not as strict on assumption testing as a Pearson correlation is. Another example we have here is if you have a dichotomous variable like gender and a continuous variable like self-esteem, if you're looking at the association between a dichotomous and continuous variable, you do a point biserial correlation. And we'll talk about a different way of looking at this. You could do a t-test in this case, but that's not really looking at relationship, that's looking at differences. A t-test is looking at differences, whereas a correlation is looking at the relationship or association. We have a nominal to nominal comparison. So the relationship between gender and ethnicity. We have 2 categorical variables here. In this case, you could use a chi-square test of independence to see if there's a significant association between gender and ethnicity. The next test family is quite similar. So if you're doing a correlational design, correlational designs branch off into correlational analyses, which is what we just touched on, and they branch off into predictive analyses. So if you see the word predictive, you can 99% be sure that you need to run regressions. Regression means you're trying to predict an outcome. So there are different combinations here, and the important takeaway is that it doesn't matter how your predictor variable is coded. You can have any type of predictor variable, continuous, ordinal, or nominal. The choice of regression model depends on your outcome variable or your dependent variable, also called a criterion variable in a regression model. So if you have a continuous outcome, like what is the predictive relationship between age and self-esteem, you would use a linear regression model. You could also input multiple predictors here. So instead of just age, you could put age, ethnicity, education level, income bracket. How do those predict self-esteem? That would be a multiple linear regression because you have multiple predictor variables. You can predict a dichotomous outcome. So passing and failing of an exam, those are two mutually exclusive groups. You either pass or you fail. So that is a dichotomous nominal variable, in which case you don't use a linear regression, you use a binary logistic regression. So if you see the word logistic, that means your outcome is most likely ordinal or categorical. The binary here means that we have just two possibilities for the outcome, passing and failing of an exam. You have more than two possibilities, then it's called a multinomial logistic regression. So if you're trying to predict ethnicity or potentially education again, you could use a multinomial logistic regression because ethnicity has more than two possibilities. The final type of regression model is when you're predicting a ordinal outcome. Okay, so income bracket, there's a natural progression to it. It's kind of like a multiple choice, but say you didn't know someone's specific income down to the dollar and cent, then you would do a multiple choice and say someone says they're 40,000 to 50,000 on income. Someone else says they're 70,000 to 80,000 on income. It's multiple choice, so this would be a ordinal variable, meaning it's an ordinal logistic regression. Okay, so continuous outcome leads to a linear regression. Binary or dichotomous outcome, you have a binary logistic. If you have more than two possibilities, you do a multinomial logistic. And ordinal logistic would be if you have an ordinal outcome variable. So what have we touched on now? We've touched on just a significant relationship between variables, and I'm going to come back to this slide for just a second because I need to discuss independent and dependent variables. So on the correlation slide here, you don't necessarily need an independent or dependent variable. You just need two variables of interest. So it doesn't matter if self-esteem or self-efficacy is your independent or your dependent. The purpose of a correlation is that it's a two-way relationship. It doesn't matter whether one influences the other or vice versa. It's looking for a general association. You don't need independent and dependent variables. Whereas on the regression slide here, you do need to identify what is your outcome. That's the most important thing. So your outcome is going to determine what regression type you use. Here we get to differences. Okay, so this is the key word, not predict, but is there a difference in a variable or variables between groups? So if you have a continuous dependent variable and you're looking for differences by a dichotomous variable, meaning just two possibilities, you do an independent sample t-test. Okay, so are there differences in self-esteem between males and females? Because self-esteem is going to be continuous and gender, we're designating to male or female, then you do a independent sample t-test. If you have three or more possibilities, then you can do an analysis of variance. That is an ANOVA. So instead of gender, say you use ethnicity here, then you can use an analysis of variance to test, are there differences in a continuous variable between those multiple groups? You can extend the idea of an ANOVA to a MANOVA. M stands for multivariate, so multivariate analysis of variance. This is used when you have multiple continuous dependent variables. So say we're looking at self-esteem, self-efficacy, job satisfaction. We have multiple dependent variables. We do a MANOVA there. Now, similar to when we were talking about parametric and non-parametric tests, you check for assumptions on a correlation, and if they aren't met, you can run a non-parametric. The same thought process applies here. So you're running a independent t-test, you want to check for assumptions, normality again. And if normality is not supported, then you can run a Mann-Whitney U-test as a backup. So this first research question, are there differences in self-esteem between males and females? Our intention here is to use a t-test, but sometimes the data just doesn't come out clean enough. It's not following a normal distribution. So you can run a Mann-Whitney U-test as a backup if normality is not met. You can also run these two tests given how your dependent variable is coded. So if you have an ordinal dependent variable, like education level or like salary bracket, you could say, are there differences in that ordinal variable between two groups? That will lead you to a Mann-Whitney U-test as well. So the Mann-Whitney U-test is similar to an independent t-test, but it doesn't follow strict assumptions like normality. Likewise with the Kruskal-Wallis test, a Kruskal-Wallis test can be used as a non-parametric backup to an ANOVA. Okay, so if the assumptions of an ANOVA are not met, normality is not supported for self-esteem, then you can run a Kruskal-Wallis test as a backup. But the Kruskal-Wallis also works if you have an ordinal dependent variable and you're comparing between 3 or more groups. So is there a difference in education level between ethnicities? So ethnicity has 3 or more possibilities. We can use a Kruskal-Wallis test in that example. So what we've discussed so far are all considered cross-sectional studies. You're collecting data at one point in time, and you're looking at relationships or differences. Once you go to a longitudinal design, that's where you're looking at differences over time. So you have the same population or the same sample, and maybe you're conducting an intervention. So you have a pre-test or a baseline, you administer an intervention, and then you measure the same variables at post-test, hoping to see a potential change. So here we have matched data. So it's very important that the same participants that take your pre-test come back for the post-test. You need a way to identify those people, whether it's through a numeric identifier or picking a random name from a hat. You want to match those people when they come back for a follow-up or a post-test. So if you're doing a comparison of differences over time between just 2 points in time, you can do a dependent sample t-test. Your variables need to be continuous to use this. So differences in job satisfaction between 2 points in time, that would be a dependent sample t-test, or it's called a paired sample t-test as well. Taking that idea and extending it and adding one more time point, pre, post, and follow-up, use a repeated measures ANOVA in this example. So it looks very similar to our previous one, but you've just included a final time point. So pre-test, post-test, and a follow-up done at some point in the future. The non-parametric alternative to a dependent sample t-test is called a Wilcoxon-signed rank test. So this is used either when you have an ordinal variable like income bracket, and you're trying to see, is there a difference between pre and post-test? But it can also be used if your assumptions of a t-test are not met. So if you check for job satisfaction, how well does it resemble a normal distribution? And that assumption is not supported, then you can run a Wilcoxon-signed rank test as an alternative. The non-parametric alternative to a repeated measures ANOVA is a Friedman ANOVA. So this is used when you are looking at differences in 3 or more points in time. And if job satisfaction was not following a normal distribution, then you can run a Friedman ANOVA as a backup. And you can also use it if you have an ordinal variable and you have 3 different points in time that you want to assess for differences in. The final example here is taking those 2 concepts of time and group and putting it together. So this is kind of a true experimental study. So you're randomly assigning people to treatment and control groups. You want to see, is there a difference in job satisfaction, for example, between pre and post test and by treatment control. So there are many moving parts here. You have time, you have a difference over time, pre-test, post-test. You also have differences between groups for treatment and control. And you have the interaction of those 2 concepts, time and group. The mixed model ANOVA is the big analysis to use when doing a true experimental study. So in summary, you need to determine what level of measurement the variables are that you're planning to use. You want to identify, are you looking for a two-way relationship? Are you trying to predict an outcome? Are you looking at differences between groups? Or are you testing for differences over time? So a matched pair study. And then you can use the Intellectus statistics decision tree to help you make that decision as to what is the best analysis to use. So this is Intellectus. It's our company software. It's a great tool for cleaning data. You can remove outliers. You can create composite scores. You can create various different plots. And then you can even crunch the numbers. I have a mixed model ANOVA example right here. So it's going to provide an APA write-up for you. You just input the variables that you need. It will check assumptions, and it will tell you, are there differences over time by group and the interaction effect. It will interpret all of that for you. Intellectus also has a decision tree. What I really wanted to show is if you're unsure of what analysis you need to use, you can use these options at the top. So say I want to predict an outcome. That means we're going to be using a regression. It started the decision tree right here. We're trying to predict an outcome, and then the tree branches off. So say we're using a nominal dependent variable, and say the dependent variable only has 2 levels. So I'll say, does it have more? No, it has only 2 levels. So it goes down the decision tree and specifies that a binary logistic regression is your best option here. Okay, so you can even do tests over time, so differences over time. Say we have 1 dependent variable. Do we have groups for these variables? Let's say yes. Do we have any covariates? No. So it's going to identify that because we are testing over time and we have groups like treatment and control, we need to do a mixed model ANOVA. Okay, so that's a pretty useful tool. So like I said, again, we're going to send everybody a copy of this so you can check out our previous webinars as well as the Intellectus statistics software. That concludes our webinar for today. I'll go ahead and do a question and answer session right now. If you have any questions, you can type those into the chat box. I just want to specify that Statistics Solutions provides assistance with every part of the dissertation. So we have methodologists and literature review specialists here that can help you in both quantitative and qualitative studies. We will assign a methodologist to you and a literature review specialist, and we will help you frame your paper. We can help you develop your topic. We can help you address feedback, develop research questions, crunch the numbers. We can assist with virtually every part of the dissertation. So if you have any questions, please let us know. You can email us at info@statisticsolutions.com, or you can give us a call at 727-442-4290. You see that Isades has included some links in the chat box, so you can take a look at those. I'll go ahead and answer some questions. We have a question from Megan. For a regression model, do all of the dependent variables have to be the same types of variables? I do see you have a follow-up. I may have answered that already, not positive, but there are different types of regression models. So in your study, you're not necessarily tied down to one of these. You could be trying to predict multiple outcomes, but it is dependent on how your outcome variable is measured. So again, if you have a continuous variable, that's probably the most common used, then you do a linear regression. And then there are three types of logistic regressions if you have a dichotomous, nominal, or ordinal dependent variable. All right, let's see if we have any other questions. Yes, everybody will have access to the slides after the presentation. We have a question from Bia about the previous webinars. So you'll see that when you receive the presentation, it is the third slide. You can go to the webinar archive right here. And this has a list of all the previous webinars we've done. We do 8 a month covering different topics. So you come to this page and then you can select a particular video that you want to watch. We have a question. Don't we use the ADA test as a post hoc and chi-square instead of binomial? So the ADA test is a effect size. So if you're doing an ANOVA, I wouldn't consider that a post hoc test. When you do an ANOVA, it gives a partial ADA value, and that is typically your effect size. So a post hoc test is what you do if you find significance in an ANOVA. And usually things like Tukey tests are done as post hocs. And you mentioned a chi-square test. I'm not sure which one that is for. So I did talk about a chi-square test of independence. That's used right here. If you have two nominal variables, a chi-square test of independence is used. It is also the test statistic when you're doing a logistic regression. You'll see a chi-square value. Okay, so we have a question. How would you recommend approaching a trend analysis of social media tweets? So you could do potentially this would be modeling, and I just blanked on the name, but we do have it in Intellectus here. So let me open that. It's right here. So analyses and time series. Potentially a time series analysis could be used for something like that, trend analysis of data over time. So that's a REMA. It could also be done descriptively or exploratory analysis. You just look at the usage rate over time. That could be an alternative way of using it. But it sounds like time series is probably what would stand out to me. Okay. If my research problem is to find the influence of socioeconomic status of family and its effect on students' GPA or learning, what method would I use to collect data on this, or would this be a correlation? Okay, so a couple questions there are, what method would I use to collect data? So collecting data, there are a couple options. You could use SurveyMonkey or Qualtrics. You can actually pay those organizations to target a specific demographic for you, and they will pay people to take the survey. So that is how you can collect data. You can also find your own population. You can do the targeting of people and then host the survey on SurveyMonkey or Qualtrics. Yes, this sounds like a correlation. If your outcome is GPA, it depends how GPA is being measured. If GPA is a fill in the blank response, whereas participants give their specific GPA 3.2, 3.6, whatever it may be, it's considered continuous at that point. So you could use a Pearson correlation potentially. It also depends how socioeconomic status is being coded. Potentially, I'm going to assume socioeconomic status is ordinal. So I would say potentially a linear regression is what you need. And that's if GPA is continuous, it's a fill in the blank response. If it's a multiple choice response where it's like GPA is 1 to 1.9, and then 2 to 2.9, and 3 to 3.9, then that's an ordinal GPA variable. I would say do an ordinal logistic regression in that case and have socioeconomic status as a predictor of GPA. Okay, so it sounds like a linear regression or an ordinal logistic regression. You could also look at it as a correlation, but with an ordinal socioeconomic status variable, it gets a little messy. I would probably just say do a regression. Okay. We have a question, are the decision trees available by plugging in my groups? The decision tree is 100% just an open software. You don't have to enter any data to do this. It's just based on the level of measurement that you know your variables are going to be. So you don't need to specifically put in your variables or your groups. You just need to know what type of variables you have for this decision tree to work. Okay. Okay, we have a question. Can you talk about what regression to use if you're trying to obtain an outcome that is log odds? Changing the coefficients to a ratio number for a dichotomous DV. Let me see if I can find an example in here. We'll do a binary logistic regression. We do have example data sets in here. So choose an example data set. This is Intellectus again. And complication is the dependent, surgeon is the independent. Going to analyses, regressions, doing a binary logistic. The dependent variable will be complication, and surgeon is going to be the independent. Okay, so just to explain a few things here, surgeon, you can see all the possibilities here. Because it's categorical, it's going to do a process called dummy coding. So it's going to assign a reference group to surgeon. And that reference is listed at the top. So it's going to create 3 new variables: Jackson versus Kingstrom, Wright versus Kingstrom, and Hedderberg versus Kingstrom. And we'll see how that predicts a complication for hip surgery. So we can see in this regression model, we have odds ratios right here, which I think is what you're probably looking for. This is what you interpret. These are the log odds of success, or in this case, of a complication, so not success, of a complication during surgery. So what this means is that first you want to look at your p-values that are significant, which are just this one, just this one. A p-value below 0.05 indicates it's a significant predictor. Surgeon Jackson is significant. Surgeon Bright, this p-value is greater than 0.05, and so is Hedderberg. This is greater than 0.05. So we don't interpret these two. We can interpret this one. And what this is showing is that those in Surgeon Jackson compared to, it was Kingstrom, okay, so those in Surgeon Jackson were 3.8 times more likely to experience a complication versus those at Kingstrom. Okay, so that's how you interpret odds ratio. It tells you the likelihood of your outcome occurring. Okay? Let me know if that answered your question. Okay, so that's for a logistic regression. Do you consider self-management behaviors measurement based on a Likert scale as a continuous or an ordinal? How can I make my case? It depends if self-management is one item or if it's a series of items that you're taking an average or a sum to develop that measure. Okay, so does self-management behaviors have one survey item, or are there multiple survey items comprising that measure? That is going to be the determination. If it's just one measure, if it's just one survey item, then I consider it to be ordinal. And then you can do a Spearman correlation. That sounds right. If it's multiple items that you're taking an average or a sum of, it's then continuous. So you could do potentially a Pearson correlation. So I do see you said it's based on a Likert scale, but how many items are part of that measure? Okay. Do you have any other questions? How can I satirize my data? I'm actually not sure of that term. Just do a Google search on it. Might be, maybe it's not spelled correctly. I'm not sure of that term, satirized. Example, I measured tall and weight, height. Okay. Standardize. Okay, standardize. So you can do that in Intellectus as well. You'll see that's checking for outliers. You can actually do it in SPSS a little more cleanly. Show you with an example data set. Intellectus statistics, I can see another question that asked, is Intellectus statistics more powerful than SPSS? That's a great question. Yes, short answer is yes, because everything we've generated in Intellectus, we've cross-referenced with SPSS, R, and Stata. So the the analyses are going to be 100% accurate. But a huge advantage in Intellectus is it gives you an APA write-up automatically by just inputting the analysis you want and what variables you want. So Intellectus is a huge advantage, and it's more user-friendly. You know, you're not going through a million menus trying to figure out how to clean your data. It's all pretty straightforward options right here: recoding, imputing, taking out outliers, creating composite scores, transforming data if it's not following a normal distribution. You can try transforming to logarithmic or cubic. So I think Intellectus is much more powerful. So to answer the question about standardized, you can do it in Intellectus, but let me show you in SPSS just because it's a little more straightforward, because in Intellectus, it's using this function right here, remove univariate outliers. So you can see what it does is it standardizes the scores. Give me one moment, I'll show you an example in SPSS for this. Okay. Find example data set. Okay, so here we have graduation rates for colleges, and to standardize these different rates, you go to Analyze, Descriptive Statistics, and Descriptives. And you'll see your continuous variables listed. So I'm going to move them all to the right box over here. And then this is the step that you need: save standardized values as variables. So once you do that and click OK, that is going to create standardized z-scores for every value. So graduation rate 2016, this is the z-score or standardized value for graduation rates. So analyze descriptives and check mark that box and then click OK. That's how you standardize. Okay, do we have any other questions? Are all instruments with the scale treated like a Likert scale for analysis? Likert scales are a specific type of ordinal item, typically following this, like strongly agree, agree, neutral. If it doesn't follow this, there is some debate about it, whether if it says neither agree nor disagree or somewhat agree. It depends. I've seen the argument both ways that even if you change the verbiage here, it's still considered a Likert scale. I think the safe bet is just to call it an ordinal scale as opposed to a Likert scale. Okay, so to answer your question, are all instruments with the scale treated like a Likert scale for analysis? In terms of analysis, yes, but the verbiage might not be called a Likert scale all the time. So you're using MTSS. What is that measuring in particular? Self-assessment, is it this one? Motivation to stop. Okay, so if there are multiple items in that and they are all ordinal, then yeah, you can use the same analyses as you would for a Likert scale. Yep. I would just be cautious using Likert scale in your methodology to define that, unless it's following this nomenclature right here. But yeah, you can use the same analyses as you would for a true Likert scale. Sounds like you might, let me see if I can find this one. Motivation. Looks like it's a single item measure. So yeah, just treat it as an ordinal variable. And most likely, on every slide, there was an ordinal test of Spearman correlations, most likely, or an ordinal logistic regression, one of those two. All right, do we have any additional questions? Yep, thanks for joining, everyone. Okay, do I also use Cronbach alpha? You can't use Cronbach alpha if it is a single item measure. So it needs to have at least 2 items in that scale to use Cronbach alpha. So I don't think there's a way to really check reliability for this because it's only one measure. Unless you're doing a validation study and you're doing multiple samples. But if you're not validating the scale, don't even worry about Cronbach alpha. Okay, very good. All right, I'll stay on for a few more minutes. If you have any final questions, let me know. Thanks for joining, April. Appreciate the feedback. Any last questions? Let's see what webinars we have coming up. And so it looks like tomorrow, my colleague Tom will be doing a webinar on the introduction chapter. And tomorrow we also have a webinar on a quantitative methodology chapter. That will be conducted by my colleague David. Yeah, so 2 overall chapter webinars, good ones to check out. Any final questions? All right, everyone, thank you for joining us. Come join us for our future webinars. Let us know if you have any questions. You will receive a copy of the webinar and the presentation. So you'll see all the contact information in there. It's at the bottom of every slide, our phone number, and you can reach us at this email address as well. So let us know if you have any questions. Have a great evening and stay safe.